Welcome to AI Podcast. I'm Jason, and today we're unpacking a fresh AAAI 2025 paper called PhishAgent, a system for spotting phishing web pages fast and accurately.
I'm Maya, and I'm already leaning in because phishing is one of those problems that keeps reinventing itself. Give me the headline first. What's the big idea behind PhishAgent, in plain English?
The short version is this. PhishAgent is an agent that looks at a suspicious page once, pulls clues from text and from the screenshot, cross-checks those clues against a big brand knowledge base and a quick web search, and then makes a call in about 2 to 3 seconds. In tests, it hit roughly mid-90s on the F1 score, which is the balance of precision and recall, and in a real web crawl, it flagged over 4,000 dodgy pages with around 95% precision.
So that sounds both fast and careful. Who's behind it?
The work is led by researchers at the National University of Singapore, including Tri Cao and Bryan Hooi with collaborators. It was accepted to AAAI 2025.
Nice. All right, set the stage. What's broken in phishing detection today that motivates this?
Classic defenses lean on blacklists or handwritten rules. Those fall behind because attackers keep spinning up fresh domains and swapping tactics. Then you've got reference-based methods that compare a page against a library of known brand pages. Those can be crisp when the brand is in the library, but they miss long-tail or regional brands. Search-based methods ask the web who a page seems to impersonate, but search results can be noisy and attackable. And lately, folks have tried throwing a multimodal large model at the page in one big prompt. That can work, but it's slower, easier to prompt inject, and not great when the model hasn't really seen a local brand before.
Right, so every approach covers part of the elephant. Where does PhishAgent fit in?
They stitch the pieces together with a simple agent plan. Think of a bouncer at a building. First, he reads the sign and the desk directory to guess what company the visitor claims to represent. That's the text extractor reading the HTML and the domain. If the sign is sketchy or the visitor is mumbling, he looks at the uniform and badge. That's the image extractor reading the screenshot and the logo. Now he asks 2 quick questions. 1, is this a real company we recognize, from our private directory or from a quick call to the front desk? 2, if yes, does the ID card domain match the company's real domain? If the company is real but the domain doesn't match, it's phishing. If the brand can't be confirmed at all, he takes a second look using the screenshot to double-check, then lets it go as benign for now.
I like the bouncer analogy. You mentioned a private directory and a quick call. What exactly are those in the system?
The private directory is an offline brand knowledge base. Tens of thousands of brands with known domains and visuals. That covers local banks, telcos, delivery firms, the long tail you might not see in model pre-training. The quick call is an online search to catch breaking or uncommon pages. Combining both widens coverage without getting stuck waiting on one source.
And why start with text before images? Wouldn't logos be the most obvious tell?
Text is cheaper and often decisive. If the HTML screams "Welcome to Brand X" and the domain is clearly not brandx.com, you can make a fast mismatch decision. But attackers can plant misleading text, which is where the image backup matters. The screenshot gives you the look and feel and the logo, so if the HTML tries to prompt the model into saying this is legitimate, the image-based pass can overrule that. They call that a recheck. It's like ignoring a noisy public announcement and trusting what you see on the billboard.
So the recheck is a guardrail against prompt injection in the HTML. How does the agent avoid getting stuck in long loops, though? I've seen other agent systems that query the web 10 times before deciding.
That's the key design choice. PhishAgent is single pass. It plans once, runs the text extractor, optionally runs the image extractor, verifies against the knowledge bases, and decides. No back and forth, no chain of mini tasks. That's how they keep latency in that 2 to 3 second window.
Got it. What did they test against to make these claims credible?
3 balanced datasets that include international pages and a set focused on Singapore's local brands, plus a live stream of 10,000 unlabeled pages where they validated what the detector flagged. They compared PhishAgent to a strong one-shot multimodal detector, a previous agent-based system that deliberates more, and a representative reference-based method. So you get a sense of accuracy and speed trade-offs across styles.
And the results, in words, not spreadsheets.
In the curated tests, PhishAgent stayed around the mid-90s on F1 while remaining faster than the agent that iterates and roughly as fast as the lightweight reference methods. In the live stream, it found thousands of suspicious pages and held precision near 95%, so most of what it flagged was truly bad. The interesting story is robustness. When attackers tried tricks like planting a fake brand name into the HTML, the recheck that looks at the screenshot pushed recall up noticeably. In other words, the image backup rescued cases where the text would have been fooled.
That's encouraging. But let me poke at the edges. What about pages that are phishing without impersonating a known brand, like a generic credential harvester that just says "sign in now"?
Great point. By design, if the agent can't identify a target brand after the text and image passes, it tends to mark the page as benign. That keeps false alarms low but risks missing generic phish. It's a gap they acknowledge and a place for future work, maybe with a separate module that checks for suspicious form patterns even without a brand.
Another question. This relies on online search and closed models. How reproducible is this for a security team that needs stability?
There's some fragility there. If the search engine behavior shifts or the model versions change, results can drift. The paper's recipe is clear, but long-term reproducibility would benefit from releasing prompts, code, and fixed snapshots of the offline knowledge base. They emphasize the architecture, and I'd love to see a public reference implementation so teams can benchmark fairly.
And the knowledge base itself. Tens of thousands of brands sounds big, but the world is bigger. What happens with niche brands or multiple languages?
Coverage is always a moving target. The offline base clearly helps with local brands, yet it still needs ongoing curation, especially for non-English markets. A practical deployment would set up a pipeline to add brands as they appear and to localize across languages. Think of it like antivirus signatures, but for brands and domains with broader semantics.
What about cost and throughput? 2 to 3 seconds per page sounds good, but does it translate to production?
For a SOC that screens prioritized URLs, yes, that's practical. You pay for 1 or 2 model calls plus search. For massive crawlers at internet scale, you'd still want a tiered system. Start with cheap heuristics to filter the obvious stuff, then send the hard cases to PhishAgent. The paper's ablations suggest you can trim components when you need lower cost, at a measured accuracy trade-off.
Can you give an example of how a tiered setup might look in the real world?
Picture an email gateway. Stage 1 checks known bad domains and simple rules. Stage 2 runs a lightweight visual logo detector to catch blatant spoofing. Stage 3 is the agent, which reasons over brand identity and domain mismatch. If the agent says phishing with high confidence, you quarantine. If it says benign but the user still clicks and types a password, downstream behavior analytics can still catch account compromise. Defense in depth.
I like that. Back to the experiments for a second. You mentioned F1. For folks who don't live in metrics, why does that matter more than just accuracy?
Accuracy can be misleading when the class balance shifts. If most pages are benign, a lazy model could say everything is fine and still look accurate. F1 combines precision and recall. Precision answers how many of the flagged pages were actually bad. Recall answers how many of the bad pages you caught. High F1 means you're doing well on both, which is what you want in phishing defense.
Right, balanced performance. Any other caveats we should call out?
One more. In the live stream, they validated the positives to compute precision, but they didn't label a sample of the negatives. That's practical, but it means we don't know recall on that stream. In deployment, teams should periodically label a slice of unflagged pages to estimate what slipped through.
Exactly. So if I'm a security lead, what's the concrete takeaway from this study?
Build your phishing detector like a quick, careful bouncer. Start with text, then confirm with vision. Keep a private brand directory, but also peek at the web for fresh context. Decide in one pass so you can scale. Add a targeted recheck to resist prompt injection. And measure not just accuracy, but how long it takes and how much it costs.
And if I'm a researcher looking for the next paper, where would you push?
3 directions. First, broaden adversarial testing beyond simple text tricks to include CSS overlays, multilingual lures, and more realistic logo spoofs. Second, cover non-brand phishing by looking at suspicious form flows and network indicators. Third, expand the offline knowledge base globally and make the pipeline reproducible with public releases and fixed snapshots.
That sounds like a solid roadmap. Before we wrap, let's give credit where it's due. This is thoughtful work from NUS, led by Tree Cow and Bryan Hooi, and it lands in that sweet spot of accurate and fast, which is rare in agent systems.
Totally. PhishAgent shows that you can get the benefits of agentic reasoning without paying the price of long, slow tool loops. It's pragmatic, and it's a good pattern for practitioners to emulate.
Quick recap for listeners. PhishAgent fuses a brand knowledge base and web search, uses text first and image as backup to extract the brand, checks the domain for mismatches, and makes a single-pass decision. It hits strong accuracy while staying speedy, and it's more robust to simple injection tricks because of the image recheck. The main cautions are knowledge-based coverage, reproducibility with closed tools, and blind spots for generic phish.
That's the takeaway. If you're building defenses today, you can apply the blueprint right away, even if your exact tools differ. And if you're evaluating products, ask vendors about brand coverage, single-pass latency, and how they guard against prompt injection in HTML.
All right, we'll leave it there. This has been AI Podcast. I'm Maya. Thanks for listening.
And I'm Jason. Stay safe out there, and we'll see you next time.